This is the video for your notes on SOL 6.10 or Geometry Formulas. It covers pages 73 through 82. You'll need a pencil and 5 highlighters or pencils with colors pink, orange, yellow, green, and blue. A closed shape made up of straight sides is called a polygon. Sides that are the same length, angles that have the same measurement in degrees, or shapes that are an exact copy of each other. So here, if these two lines are congruent, these two angles are the same size, and these two shapes are the same size, then we use this symbol and say that those geometric shapes or figures are congruent. A polygon with 3 sides, like these shapes here, is called a triangle, and tri means 3, like a bike has 3 wheels. A polygon with 2 pairs of congruent sides and 4 right angles. The main thing that you need to look at is that it has 4 right angles. And if it has 4 right angles, we have a rectangle. And rectangle has angles, so we're looking at those angles. Now, a polygon that's a special type of rectangle that has 4 congruent sides. So the important part is that it has 4 congruent sides and it has the 4 right angles needed for a rectangle. So technically it's a rectangle and a rhombus. And this is called a square. The distance around a polygon. So if I go all the way around and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I just counted 16 units all the way around that shape or that polygon. That is called the perimeter. The measurement of how much space a shape covers. This is measured by counting the number of 1 by 1 squares that can fit inside the shape. So I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and I just saw how much that highlighter is covering that rectangle instead of going around like the perimeter. So when I'm covering something with squares, I am finding the area. A shape that's made up of points that are all the same distance away from a single point called the center. So if I look at the center and I measure out 2 centimeters out for this circle, we get that circle that's around the center J, and each of those little lines is 2 centimeters, so they're all the same distance from that center point. And this shape is our circle. The middle point of a circle, the middle or the center of a circle, we call it the center. A line that runs from the center to the actual circle, and it measures halfway across the circle. So here we have halfway across the circle. That measurement is the radius. A line that runs all the way across a circle and goes through the center is called the diameter. And if I kind of look at half of that circle, the diameter made a capital D with the circle. That's how I remember which one's diameter and radius. Now, if I wanted to know the distance around a circle, and it's similar to the perimeter, I'd go all the way around the circle, and when we're finding the perimeter of a circle, we give it a special name, and it's called the circumference. circumference. Now the constant ratio that's comparing that circumference that goes all the way around a circle to its diameter is the ratio or fraction of C, circumference, divided by D, diameter. So if I unwind that circumference and lay it out, and I take the diameter and lay it on top of that circumference, I see that I could fit the diameter 1, 2, 3 times plus a little bit more. And that little bit more that the circumference has that the 3 diameters don't is where we get to pi. So we see that pi is a little bit bigger than 3 because there's a little bit more than 3 diameters that fit on that circumference. Now the shape that measures how much space a shape, the measurement of how much space a shape covers is area. And the area of a square is pi r squared. So we use that to kind of estimate what our area is because the circle kind of covers parts of some squares. So the radius is 2 and 2 squared is 4. So I see one group of that r squared, or 4 boxes, and I can take a little bit here and make another box, a little bit there, make another box. So I have 1, 2, 3, 4. So I have about a second group, and I have about a third group of 4 here. So it's about 3 groups of the right r squared, or 3.14 pi groups of r squared. A 3D figure with 6 rectangular sides, which are called faces. So I have 6 different sides, and each side is a rectangle. So we're going to have a rectangular prism. A side of the 3D figure, so you could have the top, bottom, front, back, left, or right of a rectangular prism, and these are called, one of these sides is called the face. Okay, so if I highlight one of these, just this rectangular side is called the face, where 2 faces meet to make a line. So 2 of those faces meet and they make a line here, and that is called an edge of the rectangular prism. Where 3 faces meet to make a point, I have the 3 faces and they all touch at that point. This is called a vertex of the rectangular prism. The number of cubes that would fill up a 3D shape, I look and I see that I have 4 different layers, and if I take those layers off, each one has a 2 by 3 or has 6 different ones, and then 6 times 4 is 24. So we just figured out the volume, or how many cubes would fill up that rectangular prism. If I want to know the number of squares that will cover a 3D shape, I can kind of unwrap the wrapping paper that covers that box and see what the area of each of those 6 faces is going to be. So I find the area of each of those faces, or each of those surfaces. So the whole thing is called the surface area when I find the area of each of those rectangular faces. So the ratio of the circumference to its diameter is pi. So if I'm looking at the circumference is the distance all the way around the circle. So if you measure all the way around that circle, you want to know how many times does the diameter fit into that or divide that. So this is the diameter, and I'm going to wrap that around the circumference, and I see that it wraps around 1 time. So the diameter fits on the circumference 1 time, and then the diameter fits on the circumference a second time. So that's the second time that it fits on the circumference, and then the diameter fits on the circumference a third time. So it fits 3 times with a little left over, and that's where the 0.14159 and all of the decimals that keep on going but never repeat end up. So the circumference is being divided into pieces that are as big as the diameter, and the diameter goes into the circumference about 3.14 times. And this is an example of pi, or this is the mathematical symbol for pi. The squares covering a circle is measuring the area. We need to remember that area is always covering any shape or any surface. And the distance around the circle is measuring circumference. So basically the perimeter of the circle, or the distance around, if I take a string and wrap it around and I lay it out, I can measure with a ruler what the circumference of that circle is. Now this is an example of the actual circle. This middle line that goes halfway across the circle is called the radius. And this point in the middle, or the center, is called the center. Now this is pointing to the line that goes all the way across and goes through the center, and this is called the diameter. Now if you forget which one's the radius and diameter, you have a formula sheet that shows you which one's is which, but if I draw an R on the circle, I see that the little part of the R is part way across the circle. And if I draw a circle and draw a capital D for diameter, I see that the capital D goes all the way across the circle. And that's how I remember which one is the diameter and which one is the radius. Now, if I want to go around a polygon, I would measure that distance all the way around. I could figure out how much that is with a string and lay it out, or I could go all the way around a circle with a string, lay it out, and that's going to be the perimeter or the circumference. And that's going to be normal units because I'm just measuring with a ruler. If I want to figure out how many squares cover a polygon, cover a circle, or cover the outside or surfaces of a prism, that's going to be area. So if I want to cover a polygon, I'm going to look for the A formula underneath the polygon, or this, if I want the area of a circle, look for the A formula underneath the circle, and if I want the surface area of a rectangular prism, I'm going to find the S dot A dot formula underneath that actual shape. So for volume, if I'm trying to fill a prism with cubes, so the units are going to be cubes, and I want to use the formula that has V equals that's underneath that actual shape. So since I'm measuring with a normal ruler for perimeter and circumference, they're going to be normal units like centimeters, meters, inches, or miles. And if I'm covering something with squares, I'm going to have units squared. So centimeters squared, meters squared, inches squared, miles squared, because I'm covering it with squares. And if I'm filling something with cubes or 3D objects, I'm going to have centimeters cubed, meters cubed, inches cubed, or miles cubed, or any other unit would be cubed. For this next shape, we have a rectangle, and we want to find out the area and the perimeter of this rectangle. So we need to look at the formula sheet. And I don't want you making up your own formulas. If I see that I want the area of this rectangle, then I'm going to go over to the rectangle, and area, the abbreviation for the area of this rectangle, we have that area means A, or is abbreviated for A in these formulas. So if I'm looking at the area of the rectangle that's on your formula sheet, you look for the formula that says A that's underneath that shape. And I'm going to write that formula here, and I'm going to use that formula when I want to find the area of that rectangle. So area equals L times W. And L means length, and W means width. So I need to find out what the length and the width, since those are the two measurements in my formula that I need to substitute for, I need to find out the value in my own rectangle. So I want to find L, and if I look back in the picture, I see that L is the measurement that's going across, but it could also be going across the top. So I know that this measurement would be L, and that is 5 feet long. So I'm going to put 5 in for the length. And when I'm looking at the width is the up and down measurement. So we'll highlight that green. So you could see that measurement on either side, or the two sides that are congruent and opposite and parallel. So we see that the width is 3 feet. So I can put parentheses because when I have two letters next to each other, that means multiplication. So I'm going to put the length of 5 and the width of 3 in the same locations in the formula. So I'm going to replace the letter with its value, and I'm going to replace each letter with its value, and 5 times 3 ends up being 15. So now I know that area is supposed to be squared units. So I am covering that shape with 15 squares that are each a foot long. So it's going to be 15 feet squared as my final answer for the area. Now that I'm trying to find the perimeter, I am going to look for the perimeter formula underneath the rectangle because we have a rectangle. So perimeter, when I'm looking at the abbreviations, perimeter has the letter P. So P, the formula that says P equals underneath the rectangle, or the shape that we have, is the formula that we would need to write. So the perimeter equals 2L plus 2W. However, you can always use that the perimeter of any polygon means to add all sides. So if you would like to just add all 4 sides, you can use that alternate formula that won't be on your formula sheet, so you need to remember it. I'm going to write the perimeter formula and show you how to use it. So 2L plus 2W, we know that L is 5 and W is 3, so 2 times whatever L is plus 2 times whatever W is. We're going to put the L, or length, in as 5. And then we're going to put the width in as 3. So we're going to write a 5 in for the length and 3 in for the width. And if I look at PEMDAS, I see 2 multiplications and 1 addition. And we see that we're going to need to do all of the multiplication before we do the addition. So that's why we can do both multiplications at the same time in only this case. 2 times 5 is 10, and 2 times 3 is 6, and 10 plus 6 is 16. And we see that if I unwound the string that goes all the way around, I would have 16 feet of string. And I'm going all the way around that shape. If I want to find the area of this rectangle, I'm going to keep with the area formula that's underneath the rectangle and write area equals length times width. So in order to find this, I need to figure out what the length and width of my new rectangle is. And I'm going to substitute those values into my formula. And I know that each of these little boxes is worth 2. So if I want to find the length, I'm going to find the distance all the way across the top of that rectangle. So I would count, I have each of those boxes is worth 2, so I have 2, 4, 6, 8. When I add all of those up, and my length of the rectangle is 8 inches. So I'm going to put an 8 in for the length. Now I need the width in my formula, so I'm going to go to my picture and count what the width is. So the width is going to go in next. So the width is the up and down, and each of those little boxes is worth 2 inches, so I count 2, 4, 6. And the total width of that box would be 6 inches long. So I'm going to put a 6 in. Now that means multiplication, and 8 times 6 is 48. So I see that that is 48 inches squared, because I want to know how many inch by inch squares can be used to cover that entire box. Now if I want the perimeter, that's the distance all the way around. And I could just count all the way around by 2's until I get back to the beginning. But I'm going to show you how to use the perimeter formula that's underneath the rectangle. So I'm going to use perimeter equals 2 times the length plus 2 times the width. And if I look at the length is 8 inches. So I'm going to replace the L for 8. And if I look at the width of the rectangle, the width is 6 inches, so I'm going to replace the W with 6. Now multiplication comes before addition, so I can here do both multiplications. 2 times 8 is 16, and 2 times 6 is 12, before I complete that addition. And I see that there are going to be 28 inches that go all the way around that rectangle. If I see this triangle, I can eliminate all of the other shapes, and I'm only going to use formulas that are underneath the triangle. So if I want to find the area of that triangle, the abbreviation is A, and I'm going to use the formula that says A equals, because that's saying that the area equals. And the area equals 1/2 times the product of the base and the height. So 1/2, fraction means division, so 1 divided by 2 gives me 0.5, and a lot of you like decimals much better, and if that's the case, I would suggest keeping the getting rid of the fraction and using the decimal instead. Now the base is the bottom of the triangle that we see making a right angle. So I see the right angle here, and the base is going to be 3 inches. So we're going to replace the base for 3 inches in my formula. Next in my formula, I need the height. And on the formula sheet, I see that H for height means that we've got this other one that's making a right angle with the base and going all the way up, measuring from the base all the way to the top. And we see that that measures out 4 inches. So all of this is multiplication, and 3 times 4 is 12, and half of 12 is 6, or 0.5 times 12 is 6. So we know that we have 6 inches, and because area, we're measuring how many squares can cover it, we're going to have 6 inches squared. Now the perimeter of this, we're going to use the perimeter formula. However, here I don't see a perimeter formula, and you can't make up your own, but you can remember that the perimeter of any polygon is going to be equal to the sum of all of the sides. So if you add all of the sides up, you will get the perimeter of any polygon. So if I have a triangle, I know I have 3 sides. 1, 2, 3. So I'm going to add side 1 plus side 2 plus side 3. And here I see that I have side 1 is the same as the height, but it's not always the same as the height, and we're going to put 4 inches in. The base is always going to be one of the sides. The height isn't, but the base will be. And the last side, or the hypotenuse of that right triangle, is going to be 5 inches. So all of this is addition, and 4 plus 3 is 7, and 7 plus 5 is 12. So there's 12 inches that go all the way around. Now if I want to find the area of this next triangle, I'm going to write the area formula again. So the area, I look underneath the triangle on my formula sheet, and I see that the area, or A, equals 1/2 times the base, B, times the height. I'm going to replace 1/2 with 0.5 because 1/2 is equal to 0.5, and I'm going to replace the B with what it's equal to. So when looking for the base and the height, I want to find the right angle. Now the side of the triangle that makes that right angle is going to be your base. So my base is equal to 6 inches. So in my formula, I'm going to replace the B that stands for base with what it's equal to, and the base is, in this particular triangle, is 6 inches long. Now the height is the distance from the base to the top of the triangle. So that's not actually part of the triangle, it's just telling you how tall the triangle is. And the height in this formula is equal to 4. Now if we do 6 times 4, we get 24. And if I take half of 24, I'll get 12. So I have 12 inches, but area means I'm covering something with squares, and that's going to be 12 inches squared. For the perimeter of this triangle, I need to use the formula that means that you add up all of the sides. So perimeter of a triangle means that you add up all 3 of its sides. So side 1 plus side 2 plus side 3 will give you the perimeter of a triangle. And you need to remember that formula. Side 1 would be this one base that is one of the sides, or if I put a string all the way around, the string would be touching that side. And here we see 2 congruent marks, so this is an isosceles triangle, and we see that it's 5 inches on each of the other sides. So side 2 is 5, but side 3 is also 5. We're not going to use the green height of 4 inches because if I put a string around this triangle, it's not going to touch the height. It's going to touch the 5 inches, the 5 inches, and the 6 inches. So we're going to add those 3 sides together, and 6 plus 5 is 11, plus 5 more is 16, and the string would be 16 inches long that went all the way around. Here we have a circle, so we're going to get rid of all of the shapes that are not circles. And the only formulas that you're going to use on a circle are the ones on this part of the formula sheet that are next to the circle. So if I want to find the area of that circle, I'm going to write the formula. But the perimeter of a circle is actually called something special. It's called the circumference. So area, I'm trying to cover that shape with squares, and circumference, I'm trying to wrap a string around and see how long that string is, or how long the distance around is. For area, the abbreviation is A, and I'm going to use this formula for the area. So that says A equals pi r squared. That means that the area equals pi times the radius times itself, or the radius squared. So I know that I need to put pi in, I need to put the radius in, and then I need to square that radius. Now, it's asking for the radius, so if you give it something else, the formula is not going to give you the right answer. Now, pi is listed on your formula sheet, and you always want to use 3.14 as your approximation for pi. That's the best decimal approximation and the easiest number to work with. This next one, I need to find the radius. So if I look at the 5 centimeters, that 5 centimeters goes all the way across like the diameter. So if I go all the way across, like in my picture, that's the diameter. And I need the radius, so I can't put 5 in there. I want to find the radius, which only goes halfway across. So it goes halfway across the diameter, and if you take half of the diameter, that would give you the radius. So the radius would go halfway across, and if I take that 5 and I'm taking half of that 5, that's the same thing as taking 5 and dividing it by 2. And 5 divided by 2 is 2.5, so that radius is going to be 2.5, or 2.5 centimeters long. So the number that I'm going to put in for the radius is going to be 2.5. And that's going to be the radius, or 2.5, needs to be squared. Do not multiply by 2. Use your exponent button. So when I have 2.5 squared, that actually means 2.5 times 2.5. So you're going to put 2.5 times 2.5 in your calculator, or do 2.5 plus the square button, And we're doing this exponent first because PEMDAS says that this exponent needs to be done before the multiplication. So 2.5 times 2.5 in my calculator gives me 6.25, and we're going to multiply that 6.25 by pi. And when I multiply those two numbers together, I get 19.625. Make sure you use 3.14. And you don't press the pi button, because the pi button is going to give you a lot more decimals, and you're not going to have the same answer as the teacher. And the area is covering the shape in squares, so it's going to be 19.625 centimeters squared. For the circumference, we see two different formulas that say C equals, because the circumference is, the abbreviation for circumference is C. So I could use C equals 2 pi r and replace pi. So I have 2 times pi, which is 3.14, times the radius, which we found out to be 2.5. So we can't use the radius in this formula, or we can't use the diameter of 5 in this formula. We have to use the radius of 2.5 in this formula, because this formula asks us for the radius. So we put the radius in the formula, we put our approximation for pi in the formula, and then that's all means multiplication. So if I multiply all of that out, I can get the correct answer. Or we could have used the circumference equals pi times the diameter. So circumference equals 2 times pi times the radius. Well, that 2 times the radius kind of gives me the diameter. So these formulas are essentially saying the same thing. So pi is 3.14 and the diameter is 5. So here you have to put 5 in for the diameter. It asks for the diameter. You need to make sure you give it the diameter and not the radius. This is one of the biggest problems with these formulas for circles. If it asks for the radius, you need to put the radius in. If it asks for the diameter and says d, you need to put the length of the diameter into the formula. So now that we're solving one of the sides for circumference, we can do 2 times 3.14 for 6.28, and then I need to multiply it by that last 2.5. So if I do 6.28 times 2.5, then I'll end up getting 15.7. If I do the same thing on the right side with the other circumference formula, we do 3.14 times 5, and 3 times 5 is about 15, so it looks like these two are going to be equal. And when I actually multiply that out, 3.14, or pi, times 5 is equal to 15.7. So both gave us the same answer of 15.7 centimeters around that circle. So if I was using a string, if I wanted to find the area of the circle, I would still use the formula that says A equals underneath the circle, and A equals pi times the radius squared. So the radius is halfway across, like in my formula sheet picture, and I'm going to use the 13 for my radius. And pi is 3.14. Now I have everything I need for this formula. So we have pi times the radius of 13 squared. So we replace pi with its approximation, and we replace the radius, or r, with its measurement. And PEMDAS says I'm going to complete the exponent first, then I'm going to multiply that answer by 3.14, or pi. And 3.14 times 169 is 530 and 66 hundredths. So 530.66 inches, but area is going to be how many squares cover that shape, and your answer, or units, is going to be in inches squared. Now, perimeter of a circle has a special name called the circumference, and the circumference is the distance around, or the perimeter of that circle. So if I take a string and go all the way around the circle and then lay the string out flat, I can measure that with a ruler. And there's two different formulas for circumference. So you could have used one of these two formulas. You could have used the circumference equals 2 times pi times r. And so we do 2 times pi, which is 3.14, times the radius, which is 13. And I replaced pi with its I replaced pi in the formula with its approximation, and I replaced the r that stands for radius with the actual measurement in my particular circle. And when I start multiplying all of this out, 2 times pi is 6.28, and then I'm going to multiply by my radius of 13, and when I do 6.28 times 13, I end up getting 81.64. And I could double check that by trying the other formula as well, or the circumference equals pi times the diameter. So pi is, the approximation is 3.14, and the diameter here, I need to find out what that diameter is. So if I have two of those radiuses together, I would make it all the way across the circle for the diameter. So the diameter goes all the way across, or it makes two radiuses. And I'm going to replace the diameter here in my formula. So I have 13 for a radius here, plus the 13 for a radius here, and altogether 13 times 2, or the radius times 2, would give me a diameter of 26. So I plug pi and the diameter into this circumference formula, and all I'm doing is multiplying 3.14 times 26 for this answer. And I end up getting 81.64 again. So both formulas will give you the correct answer, and you need to choose which one works best for the particular circle. So I have 81.64 inches around my circle. For this rectangular prism, I'm going to get rid of all of the shapes that are not rectangular prisms. And I'm only going to look at the formulas for the rectangular prism when I have this particular shape. Now, you can't have area of a rectangular prism, but you could have the area of all of the surfaces added together. So I'm going to find the surface area of the rectangular prism, and that abbreviation is S dot A dot. So S dot A dot, or the surface area, equals 2 times the length times the width, plus 2 times the length times the height, plus 2 times the width times the height. This is the longest, most difficult formula. So make sure you are substituting the correct amounts. So the three measurements that I need are length, width, and height. So the length can be found at any of those three locations, and I see that here. The length of this particular rectangular prism is equal to 2 centimeters. So every time I see the L in the formula, I'm going to write the value of 2. So I have 2 times the length, which is 2, times whatever the height is, plus 2 times the length again, which is 2, times whatever the height is, plus 2 times the width times the height. So I need to find the width next, and that could be in any of those three locations. So I see that the width is 3. So every time I see the width, I'm going to write a 3 in for 3 centimeters. And the height, or how tall that rectangular prism is going to be the height. And the height of this rectangular prism ends up being 4 centimeters tall. So I'm going to input a 4 into that formula. Now, if I'm trying to figure out how to do that formula, I could look at PEMDAS, and multiplication comes before all of the addition. So if I do all of the multiplication in each of these instances and then add them up, that would still be following PEMDAS, but skipping a few steps. That's okay for only this particular problem. So 2 times 3 is 6, times 2 is 12, 2 times 4 is 8, times 2 is 16, and 3 times 4 is 12, times 2 is 24. When we add the 12 and 16, we get 28. plus 24 more would give us 52. So I have 52 centimeters, but area is when we're covering it with squares or square centimeters in this. Now this is a typo, so I didn't want you to find the perimeter. You can't find the perimeter of a rectangular prism, but you could find the volume. So if I wanted to find the volume, volume starts with a V. So we see that the volume is abbreviated with a V on this formula sheet. And V equals length times width times height for that rectangular prism. So we're going to copy that the volume equals the length times the width times the height, and we're going to replace the length, width, and height in the formula and multiply them all together in order to find out what our volume of the rectangular prism is. So I'm going to color coordinate that so we see that the length is worth 2, and we're going to multiply all of those together. So the length is worth 2, the width is 3 inches and 3 centimeters, and the height is 4 centimeters. So 2 times 3 is 6. Bring down the 4 though. Don't forget about the 4. And 6 times 4 is 24. So it's 24 centimeters, but I'm trying to fill that with cubes. So if I fill it with cubes, it's going to be 24 centimeters cubed. For this rectangular prism, I don't want to find the area. I want to find the area of all of the surfaces. So I want to find the surface area, and I'm going to use the surface area formula that's shown in yellow on my formula sheet. And I have 2 times the length times the width plus 2 times the length times the height plus 2 length times the height, and then we have plus 2 times the width times the height. So whenever I'm going to write in the height here, quite a few mistakes on these pages, and the length is green, so it's kind of twisted, but we see that that length is 8 feet, and I can put that into my formula wherever I see the length. And the width is going to be 5 feet long, and the height is going to end up being 5 feet long as well. So I have a length of 8, a width of 5, and a height of 5. Wherever we see the length, we're going to put 8. Wherever we see the width, we're going to put a width of 5. And wherever we see the height, we're going to put a height of 5. So we have 2 times width of 8. So 2 times 8 times 5 plus 2 times 8 times 5 plus 2 times 5 times 5. We're going to do all the multiplication first and then the addition. And 8 times 5 is 40, times 2 is 80. 8 times 5 is 40, plus 2 is 80. 5 times 5 is 25, times 2 is 50. Then we add those up. 80 plus 80 is 160, and 160 plus 50 ends up giving us 210. So I have 210 feet, but I'm covering that surface with squares, so it's going to be 210 feet squared. For the perimeter, we can't find the perimeter. That was a typo. Please cross it out and write volume. I want to find the volume of that rectangular prism next. So I'm going to write the volume formula of V equals L times W times H, or length times width times height would give you that volume. The length is 8, the width is 5, and the height is 5. So I'm going to put 8 times 5 times 5, and 8 times 5 gives me 40, and 40 times another 5 would end up giving me 200. So volume is how many cubes you can fill up the shape with. So your volume units are going to be cubed. So I have 200 feet that are cubed that'll fit into that rectangular prism. For this next one, we have a rectangular prism once again. So I'm only going to be using the formulas that are next to or underneath that rectangular prism. and I can't find the area, but I can find the surface area of the rectangular prism. And if I'm finding the surface area, then S dot A dot is going to be the formula that we use for surface area. And the formula is 2 length width plus 2 length height plus 2 width height. And we are going to find out what the length, width, and height are. Make sure we write height underneath there as well. So in the picture it has L, W, and H. We probably need to figure out what those three numbers are before we start using our formula. So length is kind of going to the side, and we see the height is going up and down, the length is going left and right, and the width is that 3 inches. So our length was 4 inches, so every time we see the length we're going to put 4. Our width was 3 inches, so every time we see the width we're going to put 3. And our height was 6 inches, so every time we see the H for height we're going to put 6. So 2 times 4 times 3 plus 2 times 4 times 6 plus 2 times 3 times 6 will give me my surface area. So 4 times 3 is 12, times 2 is 24. We're going to do all the multiplication first. 4 times 6 is 24, times 2 is 48. And this last set of multiplication, 6 times 3 is 18, and 18 times 2 is 36. Then we're going to add 24 and 48 to get 72. Then we're going to add the last 36, and we end up getting 108. So I have 108, and because I'm covering the surface with squares for area, it's going to be 108 inches. And this should have said volume. So run that out and write volume. Now volume we see as V, and V equals length times width times height. So I'm going to write the formula for volume of a rectangular prism if I want to find the volume of a rectangular prism. So volume equals length times width times height, and we are going to put 4 in for the length. We are going to put 3 in for the width, and we are going to put 6 in for the height. So 4 times 3 times 6 is going to give us 4 times 3 is 12, and 12 times 6 is 72. So we have a volume equal to 72 inches cubed. And it's volume, so it's how many cubes can fit into that rectangular prism. So we have 72 inches cubed. Now I want to find the surface area and the volume of this cube. So the surface area formula is going to be 2 times length times width plus 2 times length times height plus 2 times width times height. And I need to find the length, width, and height of that shape. Well, the length is going to be 7, the width is going to be 7, and the height is going to be 7. So I'm going to put 7 in for all of these measurements. So the lengths are 7, the widths are 7, and the heights are 7. So we end up having 2 times 7 times 7 plus 2 times 7 times 7 plus 2 times 7 times 7. And we're going to do each of those sets of multiplication because multiplication comes first in PEMDAS. So 7 times 7 is 49, and 49 times 2 is 98. So 2 times 7 is 98 again, and 2 times 7 is 98 once more. So I'm going to add 98 and 98 together to get 196. Then I'm going to add another 98 to the 196, and I get 294. So I have 294 centimeters, but I want to cover the surface with squares, so it's going to be 294 centimeters squared. Volume, the formula for volume is length times width times height, and we are going to put in the length, the width, and the height to that formula and multiply them all together to find the volume of that rectangular prism, or if they all have square sides, the cube. So 7 times 7 times 7 ends up giving us 343 centimeters, but volume is how many cubes can fit in, so it's going to be centimeters cubed. What is the area of the figure that's drawn below on the centimeter grid? So to set this up, we want to find the area of a triangle, so we're going to write the formula for the area of a triangle that you could see on different pages. I need to find out what the base and the height are in order to use that formula. So I need to find the height of the triangle, which is going to be where the right angle is, and that triangle from the bottom all the way to the top is going to be the height. Now the base is this bottom, which I see 1, 2, 3, 4, 5. It is 5 centimeters because it's on a centimeter grid. And I see here that the height is 1, 2, 3, 4 centimeters. So I'm going to put 5 in for the base and 4 in for the height for this problem. So 1/2 is equal to 0.5 times the base, which is 5, times the height, which is 4. And 5 times 4 is 20, and if I take half of that 20, I'll end up getting 10. So the area is 10 centimeters squared because I'm covering it with squares. That's my final answer. What is the perimeter of the figure that's drawn below on the centimeter grid? Well, perimeter for any polygon is going to be to add up all the sides. So if I look at this, I have 1, 2, 3, 4 on this side, plus 1, 2, 3, 4, 5, 6 on this side, and then I have 1, 2, 3 centimeters on this side, 1 centimeter on this side of my polygon, 1 centimeter on this little side, another 1 centimeter on this side. I have 2 centimeters, and then my last side I have that it's 1, 2, 3, 4 centimeters on the last side of that polygon. So 4 plus 6 is 10, 3, 4, 5, 6, 2 and 4 is 6, and 6 plus 6 is 12, plus 10 is 22, so it's 22 centimeters all the way around that shape. The sides of the rhombi that make up the figure shown to the right are each 4 meters long. What's the perimeter, or the distance around the entire figure? So each of these sides of the rhombuses are 4. So I'm going to label each of the sides on the outline or the outside of that shape as being 4. So just to double check that you understand where this is coming from, the perimeter is going all the way around. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 of those 4s. If I add up that 4 14 times, or just do 14 times 4, I'll see what my final perimeter is. And we see that there's 56 meters that go all the way around that, the perimeter or the outside or the outline of that shape. The picture to the right shows a portion of the roof and the 3-inch by 4-inch rectangular shingles that cover the roof. So cover means I'm probably finding the area. And if I draw a little rectangle, the 3 by 4 inches, I want to know how much space the roof needs to be recovered. So we are going to be using the area. And the area is going to be the length times the width. And the area is length of 3 times the width of 4, which is 12, and we have 12 inches squared. So for one of these rectangular shingles, we have 12 inches squared, 12 square inches that covers this. And it's saying that the dark rectangles show which shingles were damaged by the snow and need to be replaced. So I can count that I need to replace 7 of these shingles, or I need to cover 7 times that 12 inches of space. So 7 times 12 gives me 84 square inches, or 84 inches squared, of space that still needs to be covered. Seen on the right are the official dimensions for a cornhole board. Cornhole is a game where you try to toss a bean bag onto the rectangular board, and you get extra points when you toss it through the circular hole that's cut into the rectangular piece. So it's cut, it's taken away. And you want to make 2 of these boards and then decorate it with stickers. How much space would you need to cover? That means we want to know how much area we have on the board. So if I take the rectangle and I take away the circle, then I'll end up having the cornhole board, or the shape of the cornhole board. And if I'm doing cover, I need to look for these areas. So I need to find out how many stickers would cover the area of one board, but then I have 2 of them, so in the end I'll have to multiply by 2. So the first shape is a rectangle, and I'm going to write the area formula for a rectangle, which is A equals length times width. So that rectangle has area equal to length times width. The length is going to be 24, and the width is going to end up being 48. So I see that the area is going to be 24 times 48. So 24 times 48 ends up equaling 1,152. Now for the area of the circle that we're about to take away, area of a circle is pi r squared. So pi is 3.14 times whatever the radius is squared. But I need to find out what that radius is. So looking at our picture, we see that the circle is 6 inches all the way across. So all the way across is 6 inches, and that is going to be d, or my diameter. If I need the radius, I need to divide that by 2. And 6 divided by 2 is 3. So my radius is 3, and I'm going to perform that exponent first once I put that 3 in for the radius. So 3 times 3, or 3 squared, is 9, and we have 3.14, or pi, times that 9, and we're going to end up with an area of our circle being 28.26 inches squared. So I have the area of a rectangle, and then I want to subtract the area of that circle, and that would give me the area of my cornhole board. And 1,152 minus 28.26 ends up being 1,123.74, and that's for one board. So I wanted 2 boards. That means that I need to multiply that area by 2, because I have to cover twice that amount of space if I have 2 times the boards. And 1,123.74, or 1 times 2, is going to equal 2,247.48. And that's an area, and we have that all the dimensions are in inches, so that's going to end up being inches squared. So I have 2,247.48 inches squared of board space to cover with stickers.